Okay, everyone, let's get the ball rolling. And this is the question we're doing today. It's exercise 5.25. And right now, I'm about to give you guys. Okay, as I was saying, folks, we're doing exercise 5.25. So we're basically trying to estimate pi value. If you also do mathematics, or if you've done mathematics before, the symbol will seem familiar to you. Okay, it's called pi. So what we want to do essentially is to approximate its value. Okay, it's a number, it's a decimal point number with tons of numbers after a decimal point. So right now what we want to do is to approximate its value. So we gotta write a program that display the pi value for I equals to 1,000, 20,000, so on and so forth, up to 100,000. Okay, without any further ado, let's get on to it. Okay, so here's the deal. I'll initialize my I to 10,000. Once I'm done doing that, I wanna iterate for all I values, and there is 10,000, 20,000, so on and so forth. Okay, so what I'll simply do in this case is to use a while loop. And if you got that noise again, I'm sorry. I'm not all by myself where I'm actually at the moment. 1, 2, 3. Okay, so here's the deal. What I want to do is to create a variable to hold my sum, and then another variable to decide whether or not I will add or subtract a given fraction. Okay, I'll call that count, and I'll initialize it to 1. Okay. Now I wanna iterate for 1, 3, 5, 1, 2, 3, up to 2 times I. Okay, so I'll simply again use a while loop. It's entirely up to you what loop you wanna use. I just happen to use a while loop on this scenario. Okay, so 2 times I minus 1. That's supposed to be, I forgot creating my variable. Let me make it J. Let me make it a short data type. Okay, so what I'll simply do is to check if my J is less than or equals to 2 times the exact thing we have here. Okay, and this is the special case, folks, because this is where we actually gonna be adding or subtracting. Okay, hey, I'm cool. Okay, anyways, as I was saying, people are, as they passing by, they greeting, so you're gonna have to bear with me. Sometimes they want my attention. Anyways, it's because of them I included that equals sign there. So what I wanna do, I wanna check if my count is divisible by 2. If that is the case, then immediately I know I've gotta add. So I'll simply go sum, and the logic is pretty straightforward here, folks. You see, we start by subtracting, we then add, we subtract, we then add, so on and so forth. Okay, if this is the case, what I'll do, I'll subtract 1.0 divided by my J value. Okay, Okay, get off my way. Otherwise, I'll simply add divided by j. Okay, there is the special case though. Okay, now what if our j is exactly 2 times I minus 1? In that case, what we'll simply do is to add. Oh, I missed something here. I've gotta increment my count variable, and once I'm done doing that, it's time I deal with the last case. Okay, and that is when our I is actually equals to 2 times I minus j. Our j is equal to 2 times I minus 1. Okay, in that case, I'll simply add math dot. This is in fact our last term, so it's given by, let me take a look at it. It's given by negative I to the exponent of, you guys can see it, I can't even pronounce it, but you see what is it that I'm trying to do. Sure, you see what is it that I'm trying to do here. Okay, so here's what I'll do. I'll go minus 1 for my base, and my exponent is I plus 1. Okay, that is my exponent. Okay, then finally, of course, we need a semicolon. And what I want to do, since we're using a while loop, is to increment my j. Okay, regardless of the case that got executed between these two. Okay, I'm hoping we all on the same page here, folks. And if you're lost in some way, please let me know. I don't mind going through this again, explaining it to you guys. This is the final step. System.out.println we go the pi approximation, or rather, let me go the pi approximate for I equals to I is equal to I is what is 4 multiplied by sum. I don't know, it feels like I've already done this problem before, but it doesn't matter. Okay, let's hit the run button and see what we get. Oops, I forgot one thing, and that is to update my I value. So we have an infinite loop, so that's why I've got to stop it right away. And I wonder why our answer is negative. Okay, I'll simply go I plus 1, 2, 3. What could possibly be the reason for our answer to be negative? Let me see what number we're displaying here. We're displaying our sum. Okay, let me scroll up. So we created I, we then created a loop. Then inside our loop, we've got a variable to hold the sum for that particular I value. And then we've got count, which is used to determine whether or not we've got to add on our current sum. Okay. In inside our loop we've got these two conditions. We're checking if j is less than 2 times I minus 1. If that is the case, what we want to do, we want to subtract. Okay, we want to subtract 1 over j. Oh, you know what, I messed up. Did I? Oh, nope. Let me go back. So from sum, we're subtracting we should have initiated our sum. We should have initiated to 1. No wonder we're having a negative answer there. Okay, because inside these brackets we've got 1 minus 1 over 3, right? Okay. Oops. Again, it seems like I'm wrong, because initially our j will be 1. So since our j will be 1, there's no problem if we... You know what? This is the part where my mistake was. Let me change that from that to that, okay? And see what we get now. We're getting something which is even worse. One sec, folks. Let me take a look at this. Is acting weird just because I forgot dividing by j there. You can check this out on your own. In fact, it's 2 times I minus 1. So I've got to divide by 2 times I minus 1. We don't have to put that the y. Obviously, we know if this condition doesn't hold, then it means our j is already 2 times I minus 1. So that's why I'm only dividing by j. But there's something else weird too about this program, and I will show you in a sec. It does display the correct number for the first time. However, it does not proceed displaying my I value my pi approximates for other i's. It's only displaying for I equals to 1,000. Check this out. In case I decrease that number from 10,000 to 1,000, check this out. This is super weird. I don't know, perhaps I'm the one who's mistaken, and often I find myself doing mistakes like these. Check this out. You see, it works all the way from 10,000 up to 16,000, but it does not proceed even though my upper limit is, even though my upper bound is actually okay, even though my maximum number here is 100,000. At first I thought maybe it had to do with my data type, but come on, the short data type can also hold a number such as 100,000. I'm just doing it anyways for you guys to see what I did. and still this is acting weird. However, this first number here is close to pi if you know the true value for pi. Again, this thing actually stops when it's 16, and if I change my I from, if I change it to a number like 100, for instance, if I increment it by 100, I want you to see the difference. Okay, so to be honest, I don't know, maybe I'm the one with the problem. Again, it works. However, this time around it goes all the way up to 16,300 on box. This is very, very weird. I don't know why it's not working. Okay, for the last time I will use 10,000 and see what we get. In fact, you can oops, I didn't mean that. Okay, in fact, you can forget about this solution, folks, because it isn't doing what we want it to. Okay, see you on the next one though, which I hope will work okay compared to this one here. I'm gone.